Alrighty, so notes part 1. After this, you're going to be able to solve problems where projectiles are launched off a cliff at an angle of 0 degrees. Is this an example of that? No, it is not. It's just a cool graphic that I found. Okay, so when I'm talking about projectiles launched off a cliff at an angle of 0 degrees, I always think of it as sort of the stuntman driving a car off a cliff kind of thing, right? So that kind of thing. So 0, the launch angle is 0. Okay, let's begin. Now the next few pages here, the next few slides are notes if you want. Whether you write them down or not is entirely up to you. I probably won't spend a lot of time letting people get caught up. Again, I'll be posting this later, so you'll be able to have it if you want. So just kind of basic ideas that I sort of went through yesterday, sort of in a summary format. Vertical and horizontal motions behave independently of each other. That's key. Vertical and horizontal are completely independent. So you do all the horizontal stuff first, then you do all the vertical stuff next, and sort of so on. So that is to say, despite having a horizontal velocity VH, the projectile has the usual vertical acceleration of gravity. Let's just write this as AV. Vertical acceleration is 9.8. What's the horizontal acceleration? 0. Horizontal velocity is unchanging, unless there's some air resistance in the question that sort of is worded in there for you. VH stays the same at all times. That's kind of the same idea, right? The downward acting force of gravity does not affect the magnitude of the horizontal velocity. So the horizontal velocity, almost 99% of the time, remains the same throughout the problem. I'm just kind of waiting for Sam. I see her writing. Ah, okay. So then, if you spin it, there would be that whole lift force, like because of the wind, right? Like, so the wind is traveling one side faster than the other, so you would get that. I've actually seen that video where the guy does that off a, I think it's off a dam or something or other, right? Yeah, and it goes like flying straight like that, right? Remind me later. We'll see if we can find that. That was pretty cool to see. Yeah. The guy drops a basketball off a big, I think it's like the Hoover Dam or something or other, and he puts a bunch of backspin on it, and you can see the ball fall, but then it sort of takes off sideways, kind of. Okay, you got me. I'm going to go find the video. Moving on. So use the vertical velocity VV in all calculations relating to the height of the rise, time of rise, anything having to do with the up and down movement. You use the vertical velocity VV. So once again, we're back into components again. Okay, you guys, smart up. Since it's only the vertical component of the velocity which causes movement in the vertical direction, you have to literally completely separate vertical from horizontal. Okay? Now, normally we would have the clickers. I don't have them here. I don't have them hooked into this computer. I don't have the software. I apologize for those of you here that love the clickers. I like the clickers. They're awesome. Yeah, Mitch likes the clickers. I apologize. So we're going to have to do this in a slightly different way. Well, whatever. We just sort of make your note counting, right? So here's the question. A bullet is fired from a gun and air resistance is negligible. What does the word negligible mean? It means that it's not big enough to worry about. The muzzle velocity is 120 meters per second. What does muzzle velocity mean? It means how fast it's leaving the gun. It's literally the initial velocity. How far away will the bullet land if it takes 2 seconds to hit the ground? So the bullet, here's the ground. The bullet is fired like this, and it goes like that. It takes 2 seconds. Well, how far away will the bullet land if it takes 2 seconds and it's going 120 meters per second? "240 meters." Right? Pretty straightforward. Hello, ladies. You know they can hear you, Nate, eh? They can hear you. Yeah. All right. Question number 2. A rock is thrown off a cliff at an angle of 30 degrees and a speed of 10 meters per second. At its peak, what is the vertical acceleration? So the rock is thrown off like this. It's 30 degrees. The initial speed is, excuse me, 10 meters per second. At its peak, right there, what is the vertical acceleration? Are you sure? Yeah, he's right. You aren't going to fall for my silly games? Yeah, this would 10 sine 30 would be the what? That would be the vertical component, and 10 cos 30 would be the horizontal component, right? The vertical acceleration is always minus 9.8. I very rarely use the word always because it gets me in trouble. Because if you say always and then it doesn't turn out to be always, then you always said it was always, right? But the vertical acceleration is always minus 9.8. No. Jerk. Usually, because we ignore air resistance.
So yeah. The question that you give us, we can just pull negative 9.8.
Yeah, pretty much. Yep. Pretty much. Question 3, unless you're underwater, yeah. That's called the project. That's called the project principle. I might, yeah. The project principle states that the vertical acceleration underwater is not minus 9.8, thereby negating Mr. Bennett's always. Question number 3, a rock is thrown off a cliff at an angle of 30 degrees and a speed of 10. At its peak, what is the horizontal acceleration? Are you sure? I can't fool you. I know, but yet when we do it on clickers, you'd be surprised how many people pick something else. You must be paying attention, Nate. That's good. So yes, horizontal acceleration is 0, and I will say almost always. The project principle is never say always. Almost always, no air resistance. Okay, so here's a sample question. Anybody recognize that picture? The movie? It's really old. No, it's not Evel Knievel. I think that's Thelma and Louise, I think. It's not Back to the Future, Nate. Although, well, maybe. A car with an initial velocity of 24 meters per second goes off a 45-meter high cliff. Write this down. This is sample.
First of all,
write her down. I think it's Thelma and Louise. What? Thelma and Louise. Susan Sarandon and I can't remember who else. Yeah. So a car is going off a cliff at 24 meters per second. Yes, there is. You are to find the time of fall. Calculate the time of fall for an object that is dropped straight down. This is the same as the projectile. It doesn't matter that the car is going off the cliff like this. It takes exactly the same amount of time as if it fell straight down. There's really not much to the question. It's the initial velocity is 24. The cliff is 45 meters high. Okay. Okay. So how am I going to do this? Separate your horizontal from your vertical. Your VHs. It doesn't matter to this part. You're right. But we're going to start off with that, right? So the VH is the VH is the 24. The VV is the goose egg, is 0. Right? The car's going straight off the cliff, so the horizontal speed is 24, but the vertical is 0. Right? What's the acceleration vertical? Minus 9.8. That's all we really care about. So how on the distance, the vertical distance is minus 45. Does it have to be minus? It should be because it's down, and that's going to match the acceleration, which is down. Okay? So we are solving for t. So what formula do I have that has d, v, I, a, and t in it? Gee, I wonder. There's only one. VIT plus 1/2 AT squared. The D is minus 45. Is it nice when the initial velocity is 0? Oh yeah, because otherwise you end up quadratic. Right? So we're going to get minus 45 equals 1/2 of minus 9.8 is minus 4.9 t squared. I hope you can solve that with relative ease. You're going to get t equals square root. Do you get nervous when you have negative signs and roots? Right? T squared. And once again, I'm calculatorless. That doesn't look like calculating that Sam's doing, so I'll do it. I've noticed in the last 10 years, students, when they pick up their calculator, they use their thumbs. When I first started teaching, people held it in one hand and used this finger. Do you? But they do this on a calculator now. No, you don't do that, Kyle?
Oh, isn't it funny just watching these generations?
Crazy kids.
Since you said that shoe topic, like, why did you do that?
3.03? I took 45 and divided by 4.9, and then I took the square root. 9 something? You got to go 45 divided by 4.9 equals. Because that would be distance divided by acceleration. Doesn't, like, right? Because what is it, like, that doesn't equal t. I don't know what that is. Yeah, no, that is a completely separate, unproven law. 3.03 is the time it takes to fall. Which law? The PP law? Oh, the PP law is just, don't always say the word always because it gets you in trouble. Okay, how far from the base of the cliff does the car land? How far away? This is usually called the range, kind of similar to math where you talk about range and domain, although range is the y, right? So, yeah. So we are looking for that distance there. Okay? Again, this is horizontal, so we are concerned with VH being 24. Does the time have a vertical component and a horizontal component? No. Time is time. Time has no direction. Right? So the horizontal time is that 3.03. So right back to that question that we did with the bullet, right? What's the horizontal distance? T equals V times T. 24 times 3.03. So you can figure out how far away you're going to land, right? So if you're a guy making a YouTube video and you want to land in the kiddie pool, you can figure that out. As long as you don't take into account air resistance. That's what the Russians did in space, right?
Yeah, the dog's freaking out.
Poor dog. 140. No, that's not right. Nate. 72.7 meters, right? We'll see. I got another video to show you. Nate, come on. Just calm. Do you like pour Red Bull on your cornflakes, Norm? Cold. A good. What are you really saying to me? Does it like vary? Yeah, I don't know. It's a good question. I don't know. I'll have to use the Googler. What is the velocity at impact? Okay, so this is a question that comes up quite a bit at the end of problems. Nate? Okay, so what is the velocity and impact? Note that the impact velocity has two components. The horizontal remains at 24, right? Like the car is going to hit at an angle, right? So you got to do sort of vector addition here. What is the vertical component? At the start, the vertical component was 0, but because of acceleration, it's going to change, right? So, yeah. I'm recording. It's all going to be there. VF equals VI plus AT. We have to find that vertical component when it hits. We know that the vertical initial is 0. Minus 9.8 is the acceleration. And our time is 3.03. Which gives us a vertical component of I do not like this calculator. Oh my God. 29.7? Should that be negative? It's down. It should be. Is it going to matter? No, it's not going to matter. It should be negative, but it's not going to matter. So what is this impact velocity here? Those components are perpendicular. So it's pretty straightforward. V squared is going to be that, I guess technically I should write VH squared plus VV squared. And that would be Pythagorean theorem, 24 squared plus 29.7, not 3. 29.7 squared. Hey, hang on, I'm working it out. 38.2? Meters per second. Am I done with that answer there, or do I need more? Like a little more grated cheese on your pasta? Freshly ground pepper. We need the angle as well. Yeah, there's your pepper. Tan minus 1, inverse tan. Oh, man. Try that again. Theta equals inverse tan minus 1. Opposite over adjacent, so that's going to be opposite is 29.7. The adjacent is our 24. Make sure your calculator is in degrees. $51 degrees? Now, how would you describe the angle? Like north, south, how do you, what part is that? 51 degrees. In these kind of things, you would say this right here, this angle here is the 51, right? That angle up there in the corner. So we would call that below the horizon or below the horizontal, BTH.
Below the horizon.
Below the horizon. Yeah, Mitch, how did that go again? Your little thing. Wasn't that you that had the little hieroglyphic for below the horizon? Like that? Oh, like this. Okay. Okay. Remind me when I'm working. What the heck is that? Below the horizon. Yeah. Okay, so not too hard, really, right? Like, I haven't taken a lot of stuff from In grade 11, you probably could have gotten this if I told you to separate the two, right? Basically, the idea is take your vertical and your horizontal and separate them again. Okay, now, you guys probably never watched David Letterman, right? No? He looks like a goof? He was a goof. When I was a kid, I watched Letterman all the time, and he just retired recently, right? He doesn't look like that anymore. But when I was a kid, one of the things that he did was throw watermelons off buildings and TVs and various other things. So, an homage to my youth here, I'm going to say David Letterman used to throw watermelons off city buildings. It was like a fire tower kind of thing, I think. If he throws a watermelon off a 25-meter high building at a speed of 1.5 meters per second sideways, how far from the base of the building does it land? So that is, usually we do a clicker here. So I want you to do this question right now and see how you do. Okay, so, and then I'll get the video queued up for you and we'll show that at the end. Air resistance is negligible, yes. This is really the same question that I just did. All you're doing, here we got the building is 25. Here's Letterman standing up there, right? With the goofy smile. Yeah, he's a goof. He really is. Horizontal velocity is 1.5. I want to know that distance there. You do that while I do my attendance, and then I'll be back shortly. Okay, let's have a whirl at this here. It shouldn't take too long. So same steps as before. We got a 25-meter high building. The horizontal velocity is 1.5. We want to know how far from the base of the building does it land. So I just moved it out of the way to give myself some room here. That's all. So we got to find the time of fall. D equals VIT plus a half AT squared. Minus 25 is the height of the building. That's the vertical displacement. The initial vertical velocity is 0. When I heard that noise, I expected Josh to have just given you like a shot to the solar plexus was what I was expecting. But no, you were doing it all by yourself. It's right in here. Solar plexus. The gut. Never mind. Minus 25 is equal to minus 4.9 t squared. So t is going to be equal to square root of minus 25 over minus 4.9. Yep, then square root. So you're taking the square root of 5.1. 2.26 seconds. No, you take the square root of it. When you take the square root of both sides, you get t on the one side, right? Okay, now we want to find that horizontal range. D equals VT. It's really just a two-step question. What was it, 1.5? Times our new t value, 2.26. 3.4 meters. Only 3.4 meters away. I'm going to show you the video. Okay. I do have a handout of problems here. I'll have to send it to you guys out remotely there. I think I neglected to do that again, but I'll get on that right away. I would encourage you to try to do some problems. I don't see... Oh, hang on. Maybe I do. Yes, the backside has answers. It has a QR code. It doesn't have an actual link, though, but I will try to find the link and post it to School of G as well for you. So there's problems here. They aren't all of this type. They're sort of like all scattered kind of thing. So you might have some difficulty with some. On Monday, I will do another sample problem sort of set and give you some more time to work. Tuesday, we'll do another one, and then we'll get into the lab starting on Wednesday. cars and Hot Wheels. Did you bring that car in for me, Nate, that you were going to? No?
I know you like sprinkling.
Okay.
What day do you want to go out?
What do I want to do with it? I want to roll it off the table.
What day do you want to do?
Oh, later in the week. That's just there on my next slide. That's just there to remind me this question here with the guy, the chimney sweep falling off the roof kind of thing. Projectile motion. Okay, so here's classic David Letterman about 1983.